Welcome to a tutorial on using interfaces in Unreal Engine 5. I'm going to go over how to use both Blueprint interfaces as well as C++ interfaces, and also give a few examples of their uses. If you look at the chapters on this video, you'll see that some of them are labeled with explanation. These chapters go into more detail about the how and whys of what was just done. I hope that these chapters will be particularly useful if you are new to Unreal Engine, programming, or game development in general. But if this ain't your first rodeo, and you don't need those explanations, feel free to skip to the next chapter in the video using the shortcut keys Control and the right arrow key. So with that said, let's jump in. Okay, so we're going to start out here in the third person template. This is actually the third person template for the C++ version. I've gone ahead and added in this blueprints folder with the blueprint version of the third person character. I'm going to start out with the blueprint interface. Now interfaces are very useful. One of the most common uses for interfaces is for interaction systems. So that's what we are going to do here and give a couple examples of how that can work. Start out here, let's go ahead and add in an actor. This one's going to be our door. Not going to open it quite yet. Go and make another one, and we're going to make a pickup. Alright, I'm actually going to back out again here. We're going to go into here, we're going to make a new folder. I'm going to call it a UI folder. And within our UI folder, we're just going to go and use our widget, widget blueprint, user widget again, WBP, we'll just call this HUD. Alright, we'll just leave our HUD like that. We'll go back to our blueprints folder here, we'll go ahead and make our blueprint interface. So under the Blueprint tab here, hit Blueprint Interface. We'll call it BPI Interact Interface. Okay, we'll open that up. And now we're inside here, inside of our interface. We're just going to make this function, name it Interact. And we're going to add an input here. We're going to make the input of type player character, which I believe is named player? BP player BP. But if this is the third person template for you, it'll just be named BP third person character. Just call that player. Okay, now a quick explanation of what this is doing. An interface is not an actual physical actor. An interface is more of a collection of functions, and these functions have no actual implementation within your interface. So as you can see right here, our interact is grayed out. It has no function. It does nothing. It's just a placeholder function, essentially. So whenever we implement our interface by an actor, like our door for instance, we get to override what that interact function does. So in the case of a door, we can make it open the door, close the door. In the case of our pickup, we're going to make it increase our score. Interfaces are really great though, because rather than having to do a cast and a cast failed chain of say 20 different interactable objects, all you have to do is just check, hey, does that object implement this interface? And if it does, we're going to call the interact function. That may make a little bit more sense as we go along here. This is actually all we need to do for our interface. We'll go and compile that and save it. We're going to go ahead and go into our door now. Let's just add a static mesh component. Just call it door mesh. Go into class settings, implement interfaces. We're going to add in our interact interface. I'll make this pop up over here under interfaces. We're going to double click that. Bring up our event here. We're going to add a new variable. We're going to call this open. If I can spell. There we go. Alright, we're going to bring out a branch by holding B and left clicking. Drag off of that. Drag our open value into that, into the condition. And we're going to drag off our false here. And we're going to put in to set open to true. Drag off our true to set open to false. I'm going to drag off of here again. And we're going to do add timeline. We'll just call this door movement. Drag this one to the reverse end. double click to go inside of our timeline. We'll set length to be we'll go 1.5. Add in a new float track here. We'll call this movement. We're gonna add in 2 keys here. The first one's gonna have a time of 0 and value of 0. Second key is going to have a time of 1.5 and value of 1. Hit these so we can see our keys. Go back to the event graph here. Get a reference to our door mesh by holding Control and left clicking and dragging. Drag off to set relative location. Drag off to the update. For new location, we're going to drag off of that. We're going to type in lerp vector. Drag our movement into our alpha. We'll have AAA be 0, 0, 0. Our B value here, our Z, we're going to make that 150. Go back to our viewport real quick and go ahead and give a mesh here and make it look a little bit more like a door here. That should be about big enough. Okay, and this is actually all we have to do for our door. It's a quick explanation of what we just did. So anytime, like I said, when you have a class, you can go under class settings here and you can implement your interface. So in this case, we implemented our interact interface, which gives us access to any functions that interface had. So in this instance, we only have the one function, interact. So we double click that to add that event here. Can also just add it by searching for it here. We're going to check if our door is already open or in the process of opening. If it isn't, so it's closed, it's going to set that value to be open to show that it's at least opening. We're going to play our timeline. We'll get to this in just a second. And as our timeline advances, it's going to move our door up. And in the reverse action, it's going to set our door as being in the middle of closing or being closed. And then it's going to reverse to close our door. So a timeline here is basically what it says. It is a timeline. In this case, the timeline proceeds over the course of 1.5 seconds. A timeline can be very versatile and has a lot of different uses for it. In this case, we're just getting a float value that we're slowly changing over the course of 1.5 seconds here to equal 1. The reason we're doing that is because we are using a lerp to move our door here. And we're setting our relative location. So if we look at our door mesh here, this location right here, if you see it's 0, 0, 0. This is the relative location of the door mesh within the actor itself. Relative location is any component's location within its own class, its own actor. It's different from world location, for instance. So if I go out to the world here, I drag my door in, we can see its location in the world for this class is 1320 and 1160 on the X and Y axis. But if we click our component here, our door mesh, it's going to show us the relative location. And so by moving its relative location, we're opening up the door without changing the origin of our actor, which is very helpful for having the door return to its closed position where you want it to be and open how you want it to. So we'll go and delete this door for now. And a lerp here is just a blending between the values of A and B over an alpha value from a value of 0, which is going to be just the A value, and a value of 1, which is going to be just the B value. So in 0.75 of a second here, it's going to be the perfect middle of these two. So it's going to have a value of 75. And we'll get to see what this door looks like in just a second here, but we're done with our door now. So we're going to close out. We're going to go to our player now. We're going to need to add in an input. So to add in an input, we're going to first need to go into our third person and input folder here. Go under actions, go into here, go under input. Going to do an input action, IA interact. We don't need to do anything with it. We're going to back out. We're going to go to our input mapping context here, which is called IMC default. Add another mapping. We're going to map our interact function. Hit this, tap E, and let's go and throw in a gamepad support as well. Let's do the top face button here. That'd be the triangle button on a PlayStation controller. So just a real quick explanation of this, because enhanced input could be a whole video all on its own. The enhanced input system is the default system used by Unreal Engine 5 to handle users' input. There is another system used as well, but it's more of a legacy system that was used in Unreal Engine 4. The recommendation is to stick with the enhanced input system for Unreal Engine 5. The enhanced input system uses input mapping context, which is what this class that we're in right here is, and it uses it to assign what inputs work for that mapping context. So the use of this is we can assign different inputs to work and even assign which key they work with, depending on the player that we want to use and depending on what we want that player to be doing. So if we want the player to switch to, say it's a superhero game and we want them to be able to fly, but when you're flying, your movement is going to be different than when you're walking on the ground. So by using input mapping context, we can have two separate ones for our flying state and one for our walking state. And we can switch between those mappings depending on which state our character is in, which will in turn change how our character moves and functions. You may even want to have your character be able to have an extra function when they're flying. Maybe they have a speed boost button that they regularly wouldn't have access to if they were walking on the ground. But that's all we need to do for our mapping context here. We'll back out, go back to our player. I'm also going to go ahead and add in a score variable to our player. Make that of type integer here. I'm going to add in our enhanced input here for our interact. Find it right there, IA interact. Nope. Wrong one. There we go. We're going to drag off of our started value here, and we're going to do a sphere trace by channel. Our starting value is going to be get actor location. In value, we're going to use control, left click, drag off our camera, do get forward vector. We're going to multiply that by, we'll say 500. So we'll change this to a float. Well, we'll do 500, yeah. Then drag off of that. We're going to add that to our actor location. Set that as the end location. Radius, let's do about 15. Go and set draw debug for duration so we can see what this looks like. Drag off of our hit here. Break that hit result. Go and open that up. Place a branch by holding B and left clicking. Turn our return value into there. Going to do another branch here if this is true. Drag off our hit actor and do does object implement interface. Select our interact interface from the menu here. Drag the return value into there. Drag off our hit actor, and we're just going to type in interact. Just going to call that if it's true. And then we're also going to get a reference to self and pass that in as our player reference. And this will be more understandable once we do our pickup. All right, so a quick explanation of what we're doing here. Whenever we press the interact button, whenever we start to press it, so the reason we're going to use started versus triggered is triggered would just continuously go as long as that button is being pressed. So in this case, our E button, if we click it, is going to just continuously be doing this over and over. We don't want to do that. We just want it to happen whenever this input starts. And you can set up triggers to basically make it work like that. But for this, we're just going to stick with start and leave that for another time. Whenever that happens, we're going to do a sphere trace, which we'll get to that in just a second here. If our trace successfully hits something, we're going to check if that trace uses the interface we have. So we're going to basically be checking any object that we hit with it, say our door, for instance. Does it implement the interface? And if it does implement that interface, we're going to call that object's override of the interact function. So we're going to just call however that object uses the interact function there. We're passing a self-reference as the player variable here. And we'll cover that more when we set up our pickup here. Now to go over this trace here. A trace, actually a little easier to understand if we start out with a line trace. Do line trace by channel here. We'll just plug in the same start and end values here. Hook that up here. Turn on our debug. And let's demonstrate what that looks like. So a trace is essentially goes from our start location to our end location. In this case, it's a line. So it just is one line that goes from start location to our end location. And if that line has any kind of object that it can collide with, that it can detect, it will give you a little red box there to indicate that that line's path has been broken up by some object. And the trace continues past that object, but it'll turn green and it no longer will detect any object from there. So for instance, we can see that it does detect the ground, but if we try to detect the ground through our object here, it only detects the box and not the ground after it. So it only returns the hit result of the first object that blocked the trace's start and end location. Now what we can do with that is it's a great way to detect if there's an object within our range, if there's an object that we could interact with. And it'll give us what that actor is, so that hit location. It will give us the hit actor, it will give us the hit location, the impact point, the normal, the impact normal, it will give us the material that the object had on it. It gives us the specific component that we hit of that actor. If it's a skeletal mesh, it'll give us the bone name for that, as well as a few other things here. These are a little bit more niche, but they can be helpful as well. Now the reason I'm using a sphere trace instead of the line trace here is I find it gives a little bit more of a forgiving feel in terms of gameplay. So if I use a sphere trace, we can see that it's a spherical shape. It's more of a capsule than a sphere due to its length, but it will still detect our object, but it has a much wider kind of range to detect that object that we're trying to interact with. So we can see here. I find this makes it a little bit more friendly in terms of gameplay. As a line trace, if you're trying to pick up a very small object, you will have to be staring dead at it, otherwise you're not going to be able to pick up that object. But with a sphere trace, even if that object's a little small, your player could probably still pick it up by just looking where they think they should be looking. So, and that's why I use a sphere trace. It's personal preference, but I find sphere traces are more effective. So let's go and test out that door real quick and just see how that works. Go over here, hit E on it. It calls that interact interface function, opens our door. We can call it again, closes our door, and we can even change its direction while it's in the process of opening or closing, and it returns to its respective open or closed location value. And that's because we're using that lerp instead of trying to change its location over time, which can lead to inconsistent results. All right, now let's get that score set up. So we're going to open up our HUD here, and we're going to add in a canvas panel. And let's just add in a text box. We'll make this very simple. We'll just call this text box score. And we'll set a binding for the text value here. And there's many different ways of handling this, and I will admit this isn't necessarily the best way of handling it. But in this instance, it'll work for our purpose. We're going to do a cast, get player character as the object. As player BP, we're going to get score, and drag that into our return value. So now this HUD will update to always reflect what our player's score is at all times. We're going to go back to our player here, add mapping context, drag off that, the end of our begin play here. And drag off that, we're going to create a widget. we're going to create our HUD widget. Going to promote that to a variable. We'll just call that HUD. Back off that, we're going to add it to our viewport. And a quick tip here, if your nodes are ever offset like this, if you have them all selected, hold down Shift and hit the W key, and it will align them to be aligned with the top. You can also hold down Shift and hit A, S, or D to align it to the left, down, or right side as needed. Helpful little tip there. It's a quick explanation of what we did there. For our HUD, all we did was just add a canvas panel and a text block where we want our score to be displayed. For the text content, we added a binding, which will constantly run, that casts our player character, gets the player character score, turns it into a text, and puts it on our screen just to display our score. In our player character here, we created the HUD widget. So we created the widget, we added it as a variable just so we can access it for any future reference if we need it. We won't in this video, but if you ever need it, it's a good way to keep track of it just in case. We also need to make sure that we do add our widget to the viewport. Otherwise it exists, but we can't see it. So this node here just makes sure that we can actually see our HUD on the viewport. Alright, and that is actually all we will need to do for our player character here as well as our HUD. So we can close out of both of those. And we're going to open up our pickup. I'm going to go and add in another static mesh here. We'll just call the mesh pickup mesh. We'll just assign it to be, let's do a cylinder. Shrink it down just a hair here. That'll work. Alright, then we're going to go to class settings, implement our interact interface. Double click the event there. And now here is where we are going to update our score. So what we're going to do is we're going to drag off the player value here. We're going to do set score. We're going to set score to equal get score plus 1. Then we're going to destroy actor. Real quick explanation again of what we just did there. We just added in a quick mesh that we can use. Under class settings, we implemented our interact interface. We're using that interact function here to increase our player's score by 1 every time that this player interacts with this object. And then we're destroying the pickup to make sure the player can't just keep picking up the same pickup. Now, alternatively, you can also just do get score, and you could drag off of that and do increment. And this will just increase the score by 1, very much the same as using this and this. It just lowers it down to be 1 node instead of 2, but that's just an option. We're just going to leave it like this. So this kind of shows what a interface can do and the benefits of where you may want to have an input to your interface. Now this isn't necessarily the best practice to be using the player like this and increasing its score through another actor, but this is one method because there may be certain objects, like say you're picking up an item to be put in your inventory, you may need a reference to your player. Well, you can still add that to your interact interface and access it. So there's many different uses for interfaces, and there's many different uses for having an interface with inputs or outputs. So let's go ahead and add a few of these pickups on our screen here. They're pretty big. Hit play here. We'll see our score up there at the top left being covered up a little bit. That's 0. And if we pick up our pickup, comes 1, 2, 3, and 4. And again, we can open up and close our door as we need to. So that's actually it for the blueprint section of this video. Now we're going to dive into the C++ interface. Okay, so next up we're going to do the C++ version of the interface. Just a quick little explanation here first. If you have never used C++ in Unreal Engine 5, just a couple of things to be aware of real quick. This is not a full introduction into C++ or how to program. We're just going to cover some basics and just a few things to be aware of in Unreal Engine 5 when using C++. So first off, whenever you add in a new class, one way to do so is to go to your all content, your C++ classes, name of your project, have all your C++ classes here already, and also set up some folders for better organization. You can right click in there and hit new C++ class. You can also go under, I believe it's, under tools here to do new C++ class. This is also how you could add in a C++ class to a Blueprints project. So it's never too late to start including some C++ classes in a Blueprints project. You can always do that here, as well as add Visual Studio files or whatever your coding program that you're using is. Another thing to note whenever you're using Unreal Engine 5 and C++ is by default, if you add a class in from here, it's going to enable live coding. So live coding essentially will compile without closing out of your engine. So it'll compile your code, add your class in, make it visible here, and allow you to use that class within your engine, all without having to close out a project. Pretty handy, pretty useful, but it does have a few drawbacks to it. I've found several times if I'm doing live coding for long periods of time, I start getting a lot of errors that I normally don't get if I build while the project is closed. Another thing to be aware of is any live coding builds that you do, so any compiling that happens by doing live coding, you do need to still compile in your coding program, in this case Visual Studio. You still need to compile in here, going to build solution, before you try to open your project back up. Because any live coding builds are pretty much temporary and they get reset whenever you open up your project again. It's very important to remember that, because if you don't, it's very easy to accidentally cause errors that will prevent you from even opening your project at all. Now, usually you can always fix those errors by just going into your Visual Studio, or again, whatever coding program you use, and doing a build from there. And usually that'll fix it. Most often the cause of those bugs and errors is because you will make a C++ class. So let's say we make our interface class here, and we have a child class from that, right? So let's say we have a child class that is using our interface, and we have that class be in the world here. That could cause a fatal error on the system and cause the project to fail to launch. Because due to the live coding, it doesn't recognize that C++ class that is the parent of our child class even exists. So it gives a null value, and then that null value will just cause your project not to launch and just crash immediately. So that's something to just be aware of. A couple other things really quick here. If you go into your Solution Explorer here, this is at least what it looks like on Visual Studio, you'll see a bunch of different folders here. You'll see visualizers, rules, programs, games, engine. More than likely, you are not going to do anything with programs. You're not going to be doing anything with rules or visualizers. Probably you're not even going to be doing anything in engine either, unless you're trying to make changes to how Unreal Engine functions. So we're not going to worry about that either. So your project is under games, under the name of your project, which in this case is tutorial spot. All of your code files are then going to be found under source, name of your project again, and then this is all of your code files. One of these special files to be aware of here is this C# file, your .build.cs. This has all of your modules that you use for your projects. So something to just keep in mind is this is where your modules are at. If you are familiar with programming, if you're familiar with C++, then you're probably aware of what this is. But essentially, just to keep in mind, if you're ever trying to do an include, just give an example, if you're ever trying to do one of these includes here, and it won't find that include, check on the Unreal Engine documentation what module that include, that header file is from, and make sure that that module is in your build. We're not going to be doing anything with that, but just be aware that we are going to be using enhanced input. So if for some reason you do not have enhanced input here, make sure you include that here in your modules under your build. All right, so we're going to go ahead and we're going to make our interface. So in this case, we're just going to do an empty class. We'll just call it our interact interface. Ideally, you should hit this to public so you have some better organization, keeping your CPP files private and your header files public, and organize them as you would like, but we'll just keep it in the same spot for now. So it's going to probably go ahead and open up that CPP and your header files within your Visual Studio, but in the background here, if we check, it is actually going to be compiling your code still on your project. So I recommend you wait for this to finish before you start making any changes. Otherwise you may run into some issues. So we'll just give this some time and jump back in when it's done. All right, so as you can see here, it is finished. Patch creation was successful. So we can close out this, and this is the live coding window. Just keep that in mind. All right, it's gonna probably pop up this as well. Just say reload all, just make sure it recognizes all of your new files here that were added in. So first things first, we're going to go into our CPP file. We're just going to clear out all of that. We don't need any of it. The only thing we need is this interact interface header include right there. Then we'll go jump back into our header file. And once again, we're going to clear out all of this, including the include there. Just make sure you have the pragma once right there, top there. Okay, and we're going to do a U interface in all caps. And we're going to do minimal API. Then we're going to do blueprintable because we want to be able to use this in blueprints. Name this class U interact interface. It's going to inherit from the public of U interface. And we're going to do a generated body here. Because we are doing a generated body, we are going to need to include the generated version of the header file. So it's going to be the name of your header file. So in this case, interact interface with .generated added before the .h. And we're going to do another class here. This one's going to be called I interact interface. Once again, we're going to do generated body. Generate body. Going to do public. And this is where all of our functions are going to go. This first one we're going to do is a U function. BlueprintNativeEvent. Category, we'll just call it interact. Void. Interact. We're going to do another U function here. We'll just leave that one blank. We're going to do virtual void interact pure equals 0. And because we also want to be able to access our player character, we're going to forward declare our player character. The name of your player character is always going to be, you can look in your C++ files here. In this case, it's tutorial spot character, but it's also going to be preceded by an A. So it's going to be A tutorial spot character. Or declare that. I'm going to put in a pointer. We'll just call it player. Go and copy that. Paste that into here. And that is all we need to do for our interface. So quick explanation of what we just did there. In C++, interfaces are actually made out of two different classes. You have your U version of the class, and you have your I version of the class. And these names would just be whatever the name of your interface is going to be, which in my case is interact interface. The U interact interface here, this one is what inherits from U interface. This is kind of what gives it functionality and lets it work as an interface as Unreal Engine recognizes it. But a U interface has to have this I interface here, and this is what actually holds the functions that are going to be used by the interface. Now it's a little bit confusing, but that's the simplest way to explain it, really. So just think anytime you have a interface here in C++, you're going to have your U version, which is just going to be empty, and you're going to have your I version, which is what's going to hold all of the functions for your interface. So really, you can just pretty much ignore this one. You need to include it, you need to put it in here, but you don't need to worry about putting anything else in the actual class except for generate body, in which case make sure you have your generated header file right here. Your CPP file again is just empty except for the header file for your interact interface. We also put blueprintable right here to mark that this interface can be used and implemented within Blueprint. So even if a Blueprint class is not like, say, a child of a C++ class we make, it can still implement this interface here and still make use of it. But it can only make use of this one right here. This U function that is called BlueprintNativeEvent. So this right here is going to essentially mean that it is going to be looking for a blueprint override of this function. So if we're going to call this function here, this interact one, within C++, we need to do something special, and we'll get to that a little bit later here. But just keep in mind that this one here is trying to look for an implemented version of this function. That'll make more sense as we go along, but just this is your blueprint function. This one right here is just your C++ only function. It's the exact same thing. I just called it interact pure to kind of mark that is our C++ version of it. It's a virtual void, so that way we can override it and add different functionality to it depending on how we want our classes to use our interface. I put =0 here just so that it's not trying to find a function for this within our CPP file. It's not trying to find an implementation. It's basically saying that there is none within our interface class, but it can be overridden inside any class that implements our interface. Okay, so moving on here. The next thing we're going to do is we are going to go into our character and actually go and close out of our interact interface files here. Close out both those. We're going to open up our character's header file here. And we'll go and open up the CPP file since we'll need it. And we are going to need to add in the input action for our interact, as well as add in the function that's actually going to be called whenever we use the interact button. So we can go and just copy this, hold down shift, hit home if you're at the end of the line, select that whole line for you. Follow the same pattern here that's been established by Epic Games when they designed this template. Interact action. Go and put a comment there as well. We're also going to need a U property here for our score variable. Make it edit anywhere, blueprint read write, category equals score. Just call it int32 score. Next, we're going to need a new function here, our interact function. Follow the same pattern here again, void interact const f input action value reference to a value. And that's all we need to do here. We can go ahead and select this here, hit that, create the definition of our interact. Excellent. And let's scroll back up, get over here, and we're going to need to include a couple more headers here. We're going to need to include Kismet, gameplay statics, as well as the header file for our interact interface. And we'll go back down again, and we'll go to where we set up our action bindings. I'm going to set up our interact here. Bind action, the name of our input action, which is interact action. The event that triggers it. In this case, we want to use the started, same as our blueprint. It's going to trigger any function on this actor. It's going to be of this type. If I can spell. And the function we are calling is the interact function. Quick fix there, just need to change this capital C to a lowercase c. Little mistakes like that can happen. All right, now our actual interact function here is going to be fairly simple to implement. We're going to do the exact same thing we did with our blueprints. So for a sphere trace, we're going to need a hit result. So we're going to do f hit result. We'll just call it hit equals new f hit result. We're going to need the f vector for our start location, which is going to be get actor location. Going to need our end location, which is going to be our follow camera, which is the default name of the third person template camera. Get forward vector. Multiply that by 500. Add that to our start, and that's going to give us our end location. U Kismet system library. Sphere trace single. It's going to be this start and our radius, which let's say 20 this time. Then we need to mark our trace types. ECC visibility. False for we do not want trace complex. We're going to put in an empty actor array here. This is the actor array that would be used for ignoring actors, but we don't want to ignore any actors. Let's mark that we want to draw a debug line for the duration of the trace. We're going to be using that hit. And we want to ignore our character. Then, if we get a successful hit, then we're going to check if that actor that we hit uses the interface. We're going to get the actor. We're going to get the class. I'm going to check if that actor and that class implements our interface. The interface we're looking for is going to do our U version of the interface. Static class. If that is true, then we are going to do a cast to our I interact interface. Get actor interact here. Pass in a reference to ourself. This is our C++ version. Then if we're calling the blueprint implementation of it, we need to I interact interface. We're going to do execute interact. Pass in a reference to this as well. This is our blueprint version. It's giving an error here, but this is actually correct and it will work. We're actually going to change this file though, because if we are calling both of these, it's going to cause an issue later on. So we're actually going to get rid of this one. But first, let's give a quick explanation of everything we just did there. So to start out, in our header file, we added in a U property here of our score. That is the exact same thing that is in our player blueprint here. Added in our score variable here. Much the exact same thing. We did edit anywhere in blueprint read write just for ease, but we could also just do visible anywhere and blueprint read only. that would match more perfectly to what is in our tutorial spot character here. Next thing we did was we added in this uInput action for our interact action, and that is just to hold the interact action input. So when you're doing a enhanced input in C++, you have a pointer to your input actions if those input actions only exist in blueprints, which they do. And you can see that because if we go into content, input actions, all of our actions are right here. None of our actions are located in our C++ thing. So if we want to be able to use these input actions that only exist here, then we need to be able to access them by setting them up like this. That way we can edit it and assign it when we need to. So that's all that it's for. Then we need the function that's going to be called. That function is the exact same as our interact function here. That is basically what this is doing, is we're just setting up this function here. So it takes a little extra step there to get it going in C++, but hopefully that makes sense. Hopefully that kind of clears up the air a little bit. In our CPP file here, we needed to include the Kismet gameplay statics, because that is how you do sphere traces. We also need to include our interface, since we're going to be using our interface by checking if classes implement our interface and also calling functions on classes that do implement our interface. For our interact event here, we're getting our hit location, our start location, our end location, and we're doing this sphere trace here. And this may visually look a little bit more confusing than what we have right here. But if you look, it's actually the exact same thing. It's only two extra little pieces here. And that is this first one here that says this, and our hit event being placed in right here. But everything else is the exact same. We have our start, our end, radius, the trace type we are looking for, whether it's a trace complex, actors to ignore, our draw debug trace, and ignore self. And if we compare here, it's the exact same order: start, end, radius, trace channel, trace complex, actors to ignore, debug type, and ignore self. And you can actually see, if you look on your blueprint node here, it says target is Kismet system library. So that will actually tell you where the C++ version of this may be at, and that is within our Kismet system library. So just keep that in mind. If you ever have trouble trying to find a C++ version of a blueprint node, just kind of hold your cursor over it. It will tell you what the target is, and that is a good place to start looking to see if you can find the C++ version of that node. Now, sometimes they do not exist. Sometimes they may be named something entirely different. So just keep that in mind. But this right here, that just indicates that our player is the one that is doing this trace. That's all that's assigning, is that the source of this trace is this actor that we are in right now. Our hit right here, it is going to be the exact same out hit right here. But in C++, to do that, to assign that function, we need to create our hit up here. And then we're basically filling this hit result here. We're actually giving value to all the hit options there by placing it in here as a pointer. Hopefully that makes sense. And once again, we're checking here if getActor does not equal null pointer. Again, exact same things going on right here. And then we're checking if that actor implements our interface. Once again, exact same thing going on right here. Then we are calling that function. And once again, we are calling that function. Now we have these two, and this is just to show the two different versions you have of the C++ version, as well as the Blueprint version. Now I'm actually going to remove, I'll just comment out the line for the C++ version, because otherwise we will get an error later on. And I'll explain why when we get to that. For now, we're just going to be calling this version of our function, and this will call the Blueprint version. Whenever you are calling the Blueprint version a Blueprint native event or a Blueprint implementable event, you do it in this form of doing execute _ name of your function, you need to give context to what actor you're trying to call that function on. So in this case, we are calling that function on our hit actor. And then once again, same as our C++ version, we're passing in our actor, our character themselves as the reference to the player variable. All right, so now we're going to go ahead and add in, once again, another class here. We're going to add in a pickup. I'm gonna make it of type actor. We'll just call it pickup C, just to mark that it's our C++ version of the pickup. Hit create class. Once again, this is gonna pop up, but if we minimize, we'll see it's still adding code to project. So we're gonna let that compile again. Okay, now for our pickup component here, we're going to, first off, we're going to do the include for our interface, interact interface. We're going to implement it here by doing interact interface. And here we need to include both of our functions here. So we're going to start with our C++ version. We're going to do virtual void interact pure. It's going to be a tutorial spot character player. Do an override of it. Then for our Blueprint version, we're going to do void interact underscore implementation a tutorial spot character player again, and we're doing another override there. We're also going to need a mesh. We're going to do a U property edit anywhere blueprint read write category. We'll just make it mesh. Going to be a U static mesh component. We'll call it pickup mesh. Okay. And we're going to take both of these right here. Going to create declarations for both of them. Hop into our CPP file and save our header. Up here, we're going to take our pickup mesh. We're going to pickup mesh equals create default sub object of U static mesh component. Parentheses text, parentheses quotations, name of it. We're going to call it pickup mesh. Then we're going to set up the attachment for our pickup mesh. I'm going to attach it to the root component. And in our implementation here, we're going to just call our interact peer, pass on a player here, passing that player on to our interact peer here. Our interact peer, we're just going to do the exact same thing we did before. To do that, we're going to need the header for our player character. There we go. That way we can access the player score. Increase that by 1, and then we're going to destroy our self. That is our pickup mesh. Now, quick explanation of what we just did there. Within our header file here, we need to include our interact interface. Then we needed to implement that interface by adding it right here with the public I version of the interface. Over here, we did a virtual void of our interact peer. This is our C++ version of it. So we're just calling it just as it was, virtual void interact peer with the input there of our player. We're overriding that. And here, giving a typo there. There we go. Let's fix that typo. Perfect. We have our interact implementation here. A tutorial spot character, our player, we're overriding it. So BlueprintNativeEvents, they are looking for an implementation. Now ideally it's looking for implementation in a blueprint, but if a blueprint does not exist of that, then you can include an implementation within your C++ file. And this is basically just saying that, hey, the implementation is going to be in the C++ file, not on our blueprint. But a blueprint, if you have a blueprint, so we make a child of this class here, and then we create an implementation of this interact function, it will override this functionality. So even though this is overriding on the C++ version, the blueprint is going to override this implementation. just keep that in mind. Then we're just adding a useStaticMesh component, doing edit anywhere, blueprint read write, so we can customize what it is. In our CPP file here, we are just creating that mesh right here, and we're setting up the attachment, all within the constructor of our class. Now, a good way to think about the constructor is to think of it a lot like you would think of the editor. So if I open up our pickup here, in the editor here, you can see this is where our pickup mesh is. It's attached to a default scene root component. And on here as well, this is where we select our mesh. This is where we can set our collision settings, our simulate physics, as well as all these settings here. Think of all of that functionality that you do here as what you would do in your constructor for your class. It's not necessarily one-to-one, but that's more or less what you're doing here. All of that is going to be in your constructor. All of these settings right here, on your details, on your components, you set up your functions in your header file, for your components, your details for those components, that is the default values for them, you're setting them up in here. This constructor is very different than the construction script, but there is a construction script equivalent within C++, I believe it's called onConstruct. But the constructor, think of it, it's kind of like your viewport. At least that's for me, it's a good way to think of it, of whether or not I should change a setting in here. I just think, would I adjust that setting within my editor here? If the answer is true, then yeah, I just set that setting within the objects constructor. Now, as far as the effects here, we have our interact implementation, which is just, in this case, calling the interact here. And I'll get to that in just a second as to why we are doing that. Because if we go to our interact pure here, we're seeing that we are just increasing our player's score, the plus there. It's the exact same thing as right here, except instead of 3 nodes, we are doing it in 1 line of code, which is where C++ is sometimes much cleaner than what you can do in Blueprint nodes. We're then destroying the actor so that we don't just keep increasing the score. Now, the reason we're using our implementation here is because on our character, we're only calling the implementation. We're only calling that Blueprint native event with this execute interact. Because if we called both the C++ version and the Blueprint version, then this actor would end up becoming destroyed, and it would try to call this function again on a destroyed actor, which gives an assertion failure and will just crash the engine. So we don't want to do that. So ideally, you don't even have to have 2 different functions. You could just have the one function. If it's a interface that you know is only going to be used in C++, go ahead and do it this way. And then whenever you call it, go ahead and call it this way. But if you're thinking you may want to use that interface in your blueprints, or you may want a blueprint class to be able to implement that interface, or even call on functions of that interface, then you want to go ahead and just do it this way. And in some cases, you may have an interface where you want some functions to be blueprint implementable, and some functions that you want to be only in C++. In which case, yeah, that interface may have functions that look very similar to this. But in this case, really, we don't even need this one. This is just to demonstrate what that looks like. That's all we have for our pickup here. So we're going to go and compile. We're going to do our live coding here. Let that load, and we'll come back when that's done. All right, so that's finished. So we do need to make one more change real quick here. We need to make our UI work with our C++ character instead of our blueprints character. And in that case, I've already done that right here. Casting to the BP third-person character, which is actually what inherits from the blueprint of our tutorial spot character C++ class, because I did the template in C++ initially. And another thing we need to do is we need to go in here. We need to, in our event begin play, we need to create that HUD widget. We're going to add that to our viewport as well. And then the other thing we need to do is going to be adding in the interact action. We scroll down here, see this spot here, we need to add in that interact action. And that is the input action right here. This is making it visible so we can assign what input action uses that. All right, and now we should be ready to test this out. All we've got to do is drag in one of those C++ pickups here. Just drag one in, and let's just throw on a mesh there. We'll make it a big mesh, why not? All right, you can test out our sphere trace there, works as intended. Gonna walk up here, pick it up, boom, our score goes up by 1. If we see here, we can't use these ones because these are using the Blueprint version of our interface, which is entirely different from our C++ one. But we can make it work pretty easily. So if we go over to our door here, for instance, let's just delete that. Delete that function here. We're going to go into class settings. We're going to get rid of our BPI interact interface. It's going to ask if we want to make the functions that are in that interface be a part of our blueprint. We're going to say no. Then we're going to go here. We're going to implement the interact interface, which is this one here. This is our C++ version. That'll give us access to interact peer as well as interact. Now, if you'll notice here, interact peer is grayed out while interact is yellow. And that's to indicate that we cannot override interact peer. In fact, if we try to, it's not going to compile and it's just going to give us an error. We only want to override our interact file by just double clicking it there. Again, we'll just drag in the event interact there. Compile, save. Now, our C++ character can not only do the C++ pickup, we can also use our blueprint door. It's a pretty powerful system. Another thing real quick to demonstrate here is if we create a child class of our pickup here, a blueprint child class, we'll just leave it as my pickup C. If we create that child class, we can throw on a mesh here. We'll make it this cube. Actually, we'll make it this cube. Shrink it down just a little bit there. Compile and save here. If we look under class settings, we can see implement interfaces is blank. But inherited interfaces is where we will now find our interact interface. Since it's a child, it's inheriting it from a parent. Now, if you remember, if we try to override that interact function, let me see if I can find it here. Event interact here. We'll have to search for it. Sometimes it's not going to show up in here. So we'll search for it right there. So we're overriding it, even though it's already implemented. We're going to override again. In this case, we're just going to print. Just going to print a string saying hello. Right, so now if we do it, we can see it no longer works as a pickup because this blueprint version is overriding our implementation here. This implementation no longer runs. Because that goes back to where I was saying where BlueprintNativeEvents, they always check for a blueprint implementation first, and then it will check if there is a C++ implementation. And that's it for this video. I hope that was helpful. I hope that gave a good overview of interfaces. I understand this video may have been a little bit more jump cutty than some of my previous ones. But I really wanted to make sure that everything was included in there and gave detailed explanations of everything. As always, if there's any questions, feel free to leave a comment down below. I did a poll recently on what should be the next video topic. Got some votes on that, so I'm going to be making videos based on that. Let me know in the comments if there's any tutorial you'd like me to create next. And please like and subscribe if you enjoyed, and thank you so much for your time.